In this segment, we'll talk about how do we choose a criterion for linear regression. So in regression, what we are trying to do is that if somebody gives us n data points, all we're trying to do is to say that, hey, how can I best fit a particular curve to it? So here it is illustrated in the example here, or in the figure here, that this is the regression curve and these are the data points which are given to us. So one of the ways to look at it is that, hey, if I have the residual at each data point, which means that, hey, what is the difference between the observed value and the predicted value? This is the observed value at any point x of I, and this will be what will be predicted at that particular point. So this is the predicted value of y at this particular point, and this is something which is observed or given to us. So the distance between the vertical distance between the two is something which is called the residual. So one would expect that if we are trying to best fit the data, we would like to make these residuals as small as possible. So let's concentrate on a linear regression model, because that's what we are trying to do in this particular place. And we're going to see that, hey, if we are going to make a residual to be small, then other residuals might become large. So intuitively one might think that, hey, rather than trying to make one residual to be small and then making another residual small is not possible, because we'll be making one small and one large. It might be a good criterion to use is to take the sum of the residuals and make it as minimum as possible, or as small as possible. So let's go and see that whether how we can go about doing that. So we're going to take an example. Here we have 4 data points given to us, and we want to say, okay, here let's best fit data to a straight line using this criteria of minimizing the sum of the residuals. We are given the data points in a tabular form here. We're given the data points in the as a plot there. Now what we're going to do is I'm taking this straight line y is equal to 4x minus 4, which is right here, and I'm going to say that, hey, let that be the regression curve. I'm not saying that, hey, I know that it is the regression curve, but let me make a good guess and say, okay, hey, let that be the regression curve. And what I'm going to do is, in order to figure out, hey, whether it meets the good criteria of summing the residuals, making them as small as possible, the way I can do that is by calculating what the residuals at each data point are. So these are the data values which are already given to me. Now what I have to do is I have to figure out, hey, what is the predicted value at 2? So the predicted value at 2 is 4, right? From the graph you can see it. The predicted value at 3 is 8, right there as given. The predicted value at this 2 is still 4, because that's what the point is on the straight line, and the predicted value of 3 is still 8, which is because that's what's given on the straight line. So these are the predicted values, and now what I'm going to do is I'm going to calculate my residuals, which are the observed value minus predicted value. These are the observed values and these are the predicted values. So I'm going to subtract the 2. I get 0, minus 2, 2 and 0. And when I start adding all of these residuals, what do I get? 0 minus 2 plus 2 plus 0 is 0. So it seems to be that, hey, that's most probably a good that I chose a good curve by chance. So we chose y is equal to 4x minus 4 as the regression curve. So what if I wanted to choose y is equal to 6 as my regression curve and see that whether I get a similar sum of the residuals number. So in this case, this is the data which is given to us, and these are the predicted values of y is equal to 6. That's pretty straightforward, because we have our equation to be y equal to 6 for the regression curve. So all the predicted values will be 6 at any data point. And now I'm going to calculate my residuals, which are observed minus predicted, and in this case turns out to be minus 2, 0, 0 and plus 2. But when I sum the residuals, what do I get? I still get 0. So what does that tell me? That I have at least 2 different straight lines where I'm using the criteria of minimizing the sum of the residuals, and I'm getting the sum of the residuals to be 0. So one can very well say that, hey, for both of these regression models, I'm getting sum of the residuals to be equal to 0. So the sum of the residuals is minimized, and in this case it is 0. But the regression model is not unique. I cannot make it any smaller than 0, the residuals. So what we are finding out is that the regression model, but the regression model is not unique. So what that makes this particular criterion to be is not to be a good criterion because we're not getting a unique line. So let's see what we can do, if we can do any better than that. So one might realize that, hey, the reason why I was getting some of the residuals to be 0 is because I got a negative residual and a positive residual for this particular model, or for y is equal to 6 model, and then that's why I'm getting some of the residuals to be 0. So maybe what I should be doing is, rather than taking the sum of the residuals to be a criteria, maybe we should have a criteria which will minimize not the sum of the residuals, but minimize the sum of the absolute value of the residuals. So let's see whether that's going to give us any better criteria or not. So we're going to take exactly the same example with the same data, and we're going to say, hey, let's go and use minimizing the sum of the absolute value of the residuals. So we have exactly the same table and the same figure as we had for the previous one, and we're going to again choose y is equal to 4x minus 4 as the regression curve, which explains this data in the best fit. This is the data which is given to us. This is the predicted values which were done in the previous example, and now what we're doing is, again, we're calculating the residuals. The residual for the first point is 0, then minus 2, then 2, and then 0. Now when we're going to sum the absolute value of the residuals, I'm going to get a value of 4. Now again, for y is equal to 6, let's see what happens there. In that particular case also, what I'm going to find out is that, hey, I'm going to get minus 2, 0, 0, and 2 as my residuals, because that's what I calculated in my previous example. The only difference is that I'm calculating the sum of the absolute value of the residuals, and in this case I get to be 4. So what I'm finding out is that for two different regression models, at least two different regression models, that I'm getting the sum of the residuals, absolute value of the residuals, to be 4. But so again, the regression model is not unique. So as people might say, hey, if you have the sum of the residuals, which is this, sum of the absolute value of the residuals is 4, is there a possibility that, which you have not looked at, is that the sum of the absolute value of the residuals will be strictly less than 4? In fact, if you would go and take this data which we have right now for this example, you will be unable to find a straight line for which the sum of the absolute value of the residuals will be less than 4. So what we are finding out, in fact, this is the minimum sum of the absolute value residuals you will get, and you have at least two different straight lines for which you're getting the same value, same minimum value. So the regression model is not unique. If the regression model is not unique, the sum of the absolute value of the residuals is also a bad criterion. So we already talked about that, hey, can we use sum of the residuals to be a criterion? We already talked about, can we use sum of the absolute value of the residuals to be a criterion? It seems that both of them are not good criteria to use. So what we find out is that the better criteria to use is that we take the square of each of the residuals. So this is the residual itself. You take the square of each residual, you add them all up, which is called the sum of the square of the residuals. So that's why we say sum of the square of the residuals. You take each residual, square it, then you sum it, and you will like to minimize this as opposed to minimizing the sum of the residuals or minimizing the sum of the absolute value of the residuals. And how do we go about finding the minimum of this particular sum of the square of the residuals? We'll do that in the next lesson.